Okay, so for this one, basically we're going to do conservation of angular momentum. So angular momentum is L is I omega, right? And we're just going to say I1 omega 1 is I2 omega 2, right? Now we already figured out that before the moment of inertia was 1/2 mr squared plus mr squared, right? Which was, so this is the merry-go-round, this is the child, right? So that was 1/2 160 times 2 squared plus 1/2, or not 1/2, all of 45, right? There we go. And then the child is at 1.8, right? And I do believe that that worked out to 465.8 kilogram meters squared, right? So that is our first quantity, 465.8 kilogram meters squared, right? And let's see, if the merry-go-round, so 45 must be our original velocity. It's already spinning that speed, right? So I'm going to put 45 RPM. And then what's the new RPMs? Okay, so we've got to find the new angular inertia, the new moment of inertia, right? And so the new I2 is going to be 1/2 mr squared for the merry-go-round plus mr squared for the child, right? So that's 1/2 160 times 2 squared. There's, because it's 160 and it's 2 is its radius, right? Plus 45, and then they move to the new position is 0.6, right? So times 0.6 squared. So this is 320, right? Because half of 2 squared would be twice this, right? And then 45 times 0.6 squared is surprisingly small. That's only 16.2. So plus 320 is 336.2. Right, so all we're doing here is we're just using a formula 1/2 mr squared for a cylinder, right? And mr squared for just some object, right? And that's kilogram meters squared, right? So we'll plug that in here. 336.2, right? And then omega 2 is what we're looking for. Now, notice how this is in RPM. I could convert it to radians per second, but notice how the answer is in RPMs. Right? Whatever you plug in as your initial or final velocity, if you're solving for another one, you'll get the same units, and so that's what you want to do. We can just leave this as RPMs or rotations per second, or we could do degrees per minute or something like that, right? It would all work. Okay, so let's do this. So 465.8 times 45 divided by 336.2, 62.34. Oops, no, not radians per second. RPMs. Sorry. I just am used to writing radians per second. This is RPMs, and the reason it's RPMs is that we put RPMs in here. Golly.